China just unveiled something that'll make you do a double take. We're not talking about another clunky robot that moves like it's from the 1980s. No, this is different. The new wave of biomimetic robots coming out of China are so eerily human, you might actually forget you're looking at a machine. Today, we're breaking down 5 groundbreaking humanoid robots that are redefining what human-like actually means. And trust me, by the end of this video, you'll understand why the future is arriving faster than anyone predicted. Let's dive in. DROIDUP'S MOYA, the emotional robot. First up, meet MOYA from Chinese robotics company DROIDUP. And here's what makes MOYA absolutely remarkable. It's not just programmed to look human. It's designed to feel human. We're talking about micro-expressions. You know, those tiny facial movements you don't even consciously notice when someone's happy, confused, or thinking? Yeah, MOYA can do those. DROIDUP engineered MOYA with over 30 individual facial actuators. That's 30 different motors working in harmony just in the face alone. Compare that to most humanoid robots that might have 5 or 6, and you start to understand the leap we're seeing here. But it gets better. MOYA doesn't just move its face, it creates warmth. The engineers programmed subtle asymmetries into its expressions. Because here's the thing, humans aren't perfectly symmetrical when we smile or frown. One eyebrow raises slightly higher. One corner of the mouth turns up a fraction more. These imperfections, they're what make us relatable. DROIDUP'S vision isn't just about creating a robot that looks human. It's about creating a robot that makes you forget it's a robot. And with MOYA, they're getting disturbingly close. UNITREE'S G1, the survivor. Now let's talk about durability. Because what good is a humanoid robot if it can't handle real-world conditions? Enter UNITREE'S G1 humanoid. And this machine just completed something absolutely insane. An autonomous snow trek in minus 47 degrees Celsius. That's minus 52 Fahrenheit for my American viewers. That's colder than Antarctica on a bad day. Here's why this is a massive deal. At those temperatures, most electronics fail. Batteries drain in minutes. Lubricants freeze solid. Actuators seize up. Even military-grade equipment struggles. But G1? It walked for hours, autonomously. No human intervention. Just the robot, the snow, and brutal cold that would kill a human in under 30 minutes without proper gear. This isn't a lab demonstration. This is proof that humanoid robots can operate in environments where humans genuinely struggle. Search and rescue in Arctic conditions, deep space exploration analogs, extreme climate research. G1 just opened those doors. XPENG'S Iron, the hybrid. Next, XPENG'S Iron. And yes, that's the same XPENG that makes electric vehicles. They just entered the humanoid robot game, and they're not playing around. Iron is what I call a hybrid approach robot. It blends the human-like aesthetic we saw in MOYA with the industrial-grade durability of G1, then adds something unique. Advanced AI control systems that put the robot's brain front and center. Let's talk design first. Iron looks approachable. Smooth contours, proportions that match human dimensions, and a face that's expressive without crossing into uncanny valley territory. XPENG clearly studied what makes humans comfortable around robots. But the real innovation is the control architecture. Iron uses a hierarchical AI system. Think of it as multiple specialized brains working together. The top layer handles high-level decision-making. I need to pick up this box and move it to that shelf. The middle layer breaks that into subtasks. Approach object, assess weight, calculate grip force, plan path. The bottom layer executes individual motor commands, real-time balance adjustments, obstacle avoidance. What makes this special? Adaptability. Most robots are programmed for specific tasks. Iron learns. It uses computer vision to understand its environment, machine learning to improve its movements over time, and predictive modeling to anticipate problems before they happen. Harvard's knee joint. The breakthrough. Now let's zoom into a specific problem that's plagued robotics for decades. The knee joint. Human knees are biomechanical marvels. They support our entire body weight, absorb impact, allow for incredible range of motion, and do it all efficiently. Robot knees? Historically, they've been the weak point. Clunky, power-hungry, and prone to failure. Harvard engineers just changed that with a knee-inspired robotic joint that's frankly revolutionary. The results? 40% increase in strength compared to conventional robotic knees. 60% improvement in energy efficiency. And, this is crucial, impact absorption that rivals biological joints. Why does this matter for humanoid robots? Because walking is hard. Every step creates forces multiple times your body weight concentrated on joints. Most robots handle this with brute force. Massive motors, rigid structures, high power consumption. WESTWOOD'S THEMIS, the multitasker. Finally, let's talk about the holy grail of humanoid robotics, doing multiple things at once. Westwood Robotics' THEMIS just achieved something most robots can't, manipulating objects while walking. And before you say, so what? Humans do that all the time. Exactly. Humans make this look easy. For robots, it's incredibly complex. Here's the challenge. Walking requires constant balance adjustments. Your brain processes thousands of microcorrections every second just to keep you upright. Now add object manipulation, adjusting grip force, maintaining object orientation, coordinating arm movements with body motion. The computational load is massive. This is the future of service robots. Imagine a robot assistant that can walk with you while carrying items, help elderly people by providing stability and carrying objects, or work in retail environments restocking shelves efficiently. Westwood Robotics isn't the biggest name in humanoid robots, but with THEMIS, they've solved a problem that stumped the giants. What do you think? Are you excited or concerned about humanoid robots becoming this advanced? Drop your thoughts in the comments. And if you want to stay ahead of the AI and robotics curve, hit that subscribe button. I'll see you in the next one.